Hello everybody, Mr. Woods here. Just going to continue on the lesson on the law of reflection. You would have likely just looked through the PowerPoint selections and you come down to the last slide here and it really, this sums it up. The angle of incidence is equal to the angle of reflection. Seems really straightforward, and it is. But there's a lot more that can be done with that information that we'll be exploring looking at our assignment here, locating images in a plane mirror. There's geometry and mathematics behind how we can use that information. So you need to grab two tools. You'll need your protractor. That's the guy that looks like that in Geometry Kit. And you could probably be well served here as well to grab yourself a ruler. Okay, so I'll go through here the basic idea here. We're going to draw two rays, the first ray and then what we'll call the second ray. And you can use a different color for your second ray. So it's really straightforward. I'm going to go through these step by step, but we're going to draw an incident ray from the object to some point of incidence. It doesn't matter what it is. You don't have to have the same angle that I have. We're going to draw the point of incidence. We're going to draw a normal from the point of incidence. We're going to measure that angle, and then we're going to use that information to draw the reflected ray. When we draw our reflected ray, we're going to extend that reflected ray behind the mirror. Okay, so number one, we're going to draw an incident ray. So get your ruler out here. We're going to locate the 0 as close to the center of our object dot as possible. And then we're going to create an incident ray that it doesn't matter what its angle is, but I'm going to make it a nice big angle here. And let's see, we'll use blue to start. Okay, we'll draw our incident ray. I will just put a arrowhead on here to indicate that that's an incident ray. And the first thing we'll do after that, oh, being interrupted by a phone already, we'll ignore that. It's never that important. And what I'll do here is, oh, I better set this up in the proper orientation. So we're going to want to set it up right on our plane mirror. So you want, using the crosshair, this point right here, we want to place it right on the point where the incident ray touches the plane mirror. And we want the plane mirror to be right on that axis from 0 to 180 there. So that looks like a good spot right there. And then oh, that's what I'm looking for right there. Ooh, Control Z. I want to set that up to 90 degrees. You won't have that, of course, but you'll set that up using your own. Oh, Control Z. All right, maybe I do have to. I have to do something a little different than I was thinking. Here we are. I'll have to grab my own pen, and I want to put it right on the 90 degree. Oh, all right, somewhere in the middle there. So that's my 90 degrees. I'll use my ruler and I'll make that connection to the plane mirror. Now, I would highly recommend you also use a different color here. I'm going to choose black, I think, here. And we'll just make that is my normal line. And you would typically identify your normal line with the letter N just to identify it's the normal line. We need to now measure what that angle is. Okay, so and again, I'm always trying to set up this crosshair with the point right on the axes there. And for me as well to know that it's on the axes, I'm looking up here to see that it's on 90. which for some reason I'm having a hard time distinguishing. And then on here, it should be on to 0. So if I look at this, I am, wow, look at that, 40 degrees on the nose. And we're counting this from this side here. So that's 10, 20, 30, and that's 40 degrees right on the nose. So I've measured it. I'm going to take this off, and we're going to identify that as 40 degrees. And that's my angle of incidence is equal to 40. So what I'm going to do now that I have that information, is I know that the ray is coming down here, and it's going to come off at 40 degrees and off the mirror as expected here. But we're not just guesstimating it here. We need to actually measure that. So set up my protractor this direction here this time. And what we want to do now is, again, I guess I should probably move this so that you measure it from this perspective here. Just make sure I got it nice and lined up here. That looks pretty good right there. Okay, so now, again, I'm using blue here. This is my reflected angle. But so it starts 0, starts here this time, 10, 20, 30, 40. And so my 40 should be right along there. All right. Just make sure I have a good spot there. Okay, it's a little bit above that dot. All right, so I'll bring my ruler in here. And since I know that dot is a little bit off, I'm just going to put my point of reference there. And it says something like that. Should be good. All right. Now, what I want to do here, and I'm not going to move my ruler because there's a neat little trick that my ruler will do. But what I'm going to do is I'm going to draw a dotted line going back from it here. Let's see. Yes, I want a dotted line. And is it blue? Good. And I'm going to get that dotted line coming way back here. And that is the point below that we were talking about earlier. Extend the reflected ray behind the mirror and use the dashed line behind the mirror. So that's what we want to do there. All right. Now, just to label this properly, this is my angle reflected equals, that's a terrible equal sign, 40 degrees. We're basically going to do this all over again, but this time we are going to use a different angle of incidence. And the only angle you don't want to use here is an angle that is 90 degrees. So you could make another one down here if you wanted. You can make another one up here. It doesn't matter. I'm going to put one up here. And let's just see, I'm going to put this one in red. All right, so just put a little arrowhead on this just to indicate that it's a ray. And much like before, we need to measure that angle. So before we can measure the angle, we need to put our normal line on there. So normal line should be about there. Kind of under the top one. All right. Now I have an added benefit that this here, I know that my ruler is flat because it tells me so, or not just flat, but I know that it's perpendicular to the plane mirror because of the software I'm using here. You guys just make sure that you make your 90-degree mark as accurately as you can. Let's draw in our normal line. Okay, one thing I didn't mention on the last one is typically we put in a little 90-degree angle box here to indicate that it is 90 degree, if perpendicular to the plane mirror. All right, now our next step, we need to find out what that angle is. So put that on there like so. Now the only thing is I need to measure it from the normal. So I need to rotate this around. So this will be my 0, if you will. So that's 10. Okay, so it's a little over 20. It looks like it's almost 20.5. I don't expect you guys to go to the nearest half degree. So just go to the nearest degree. I'm going to call that 20 degrees. Of course, the more accurate you are, the better your results will be. So angle of incidence equals 20 degrees. And what we'll need to do now is measure off 20 degrees, and I'll just have to slide this up now. We're going to measure 20 degrees for the reflected ray. Get this lined up nicely here. That looks good there. And again, I am measuring from the normal, and I want to measure 20 degrees. Oh, there's 21, so it's going to be somewhere it's right in between that. Where did I leave my ruler? There it is. And since I know that is an exact point, I'll simply do this. And it's just kind of in between there. So that is my reflected ray. And then from the reflected ray will come my extended line to backwards. And that point of intersection right there is why I'm doing all this work, because that point right there is my image. And it should be, if we did this accurate here, it should be equidistant from the object to the mirror. So what is that? 6 centimeters, and it should be 12 there, right? And it's a little bit under, and this is a little bit under here. Now notice, see if I can get it right up there. Yeah, I think I'm a little off with my measurement tools here. You guys should be able to get even more precise on your using your hand tools there. Okay, so that's the point that we're going to label I. You found it there. You go on to the next pages. Your assignments are to determine the images for O1, O2, measure the distance from each object to its image. What do you notice? So you do that just like what I showed in the front there. And then with part B, I think part A is enough for today, and then part B will basically be doing the same thing, and then you'll be tracing in the object in between. And the practice, you guys can do as much of that as you want for practice there. If you did part A and part B today and next class, that should be plenty. All right, you guys, hope this helps. Feel free to contact me or your science teacher directly. Have a great day, guys. See you later. Bye-bye.